and what I have is I've got a number of problems I want to work through on a very, very common topic that you find on the ACT, the SAT, and many of the standardized tests that you find out there. The topic today we're going to talk about is working with proportions, ratios, and proportions. A very common topic. It's also very applicable to everyday life. So what we'll try to do is tackle a bunch of word problems and give you some pointers on how to be successful on these ratio / proportion problems. Let's take a look. All right, so the first problem we have here, notice it's a multiple choice, very common type problem that you find. What we're going to do is, as we progress with these problems, I think you'll find that there's there's a common strategy that'll assist you with these problems. The first thing we'll ask you to do is observe the fact that you're going to be given some ratios. All right, so they're going to be given some ratios, and we'll share with you what we mean by ratios. Second thing I want you to observe is that I want you to remember to label these problems, and I'll show you what I mean by that. And the final step will be to cross multiply and solve. Cross multiply and solve. Those will be the steps that we'll take for each of these problems. Hopefully the more of these we do, the more comfortable you'll be. Let's take a look at the first one. Madge wants to make some candy. She's using a recipe that calls for, among other things, 1½ cups sugar and 1/2 cup of boiling water. All right, so it calls for more than that, but these are the things that they're emphasizing. 1½ cup sugar, 1/2 cup of boiling water. She finds that she has only 1 cup of sugar. All right, so how much water will she use? All right, so we're going to follow these steps that I ask you to follow. Observe the given ratios. All right, so what I want you to first see here is she's got 1½ cups of sugar. All right, she's got 1½ cups sugar. All right, so Madge wants to make some candy. She's using a recipe that calls for 1½ cup sugar and then 1/2 cup boiling water. All right, so the ratio, first step is to observe the ratio. I want you to see that she's got 1½ cup sugar. All right, and the recipe calls for 1½ cup sugar, but she only has 1 cup of sugar. That's a ratio. All right. You can look at having a ratio in one of two ways. You could relate 1½ cups of sugar to 1 cup of sugar, or you could look at the fact that she's got 1 1/2 cups of sugar, 1½ cups of sugar, and let's relate that to having 1/2 cup of water. 1/2 cup of water. All right, so 1/2 cup of water. So whenever they relate two different things like they're doing here, 1½ cups of sugar and 1/2 cup of water, that's what we mean when we say observe the ratios. All right, the first step was to observe the given ratios, and that's the first ratio that they gave you. Every 1½ cup sugar, you need 1/2 cup boiling water. Okay, and notice how I also said you remember to label. I didn't just put 1½ here, and I just didn't put 1/2 here. I'm actually labeling 1½ cups of sugar, 1/2 cup of water. So again, you have to observe the given ratios. I did that. 1½ cup sugar, 1/2 cup boiling water. And second idea I want you to remember is to label. That's why I put the sugar here and the water here. Now we're going to set up a proportion. So now it says she finds that she has 1 cup of sugar. So the reason why it's important to label, I put sugar up here and water up here. They tell you that she has 1 cup of sugar. So now you're going to put that 1 cup of sugar in the same numerator that you have sugar up here. All right, so had I not labeled, I would not have known to put the 1 cup sugar in the numerator there. All right, now how much water will she use? That's unknown. And that's why I put the unknown variable x there where the water. They want how much water she'll use, and my unknown water amount is in the same denominator with water here. All right, so now you're going to cross multiply. All right, so we're in the third step now, cross multiply. All right, so you get 1.5x. 1.5 times x is 1.5x. And now I'm going to multiply across here. This is the third step where you cross multiply, is half. Another way to say 1.5 is 3/2. X is 1/2. So now to get this x alone, to solve for x, you multiply by the reciprocal. You divide by 3/2. Another way to say divide by 3/2 is multiply by the reciprocal on both sides. 2/3. Everything cancels here. You left with x is, and the 2's cancel here. You get 1/3. X is 1/3. So your answer there would be E. All right, so we have this problem, all these ratio and proportion problems. All right, so, and you notice a lot of these are word problems. A lot of these are word problems. We don't want you to be intimidated by problems that have words in it. I'm following the same steps for each of these problems. One problem deals with a tire. Another problem dealt with milk and water. Another problem dealt with a map. So don't be intimidated by words. Just know that we're following the same steps for each of these problems. We're identifying the ratios. Once we identify the ratios, we're careful to label. And once we label, after we label, we set up a proportion. And then after we set up the proportion, we just cross multiply. For all of the problems, don't let the words intimidate you. Don't let that frighten you. Sometimes I'm noticing students, they let the words frighten them. They think it's a much more challenging problem than it actually is. All right, enough talking. Let's get to the next problem. All right, so in a recent survey, college students on a big campus have they conducted to find the students' preferred. It was some type of experiment, a method of getting to class. The results showed that 35%. All right, so 35% of the students preferred walking to class. All right, 35% of the students preferred to walking to class. 20% of the students preferred to take the bus. All right, and then 15% of the students, they didn't want to walk, they didn't want to take the bus. 15% preferred driving to class. Maybe they had a car or something. All right, they got a car, or maybe they got a ride. And it says the remaining 35% walk, 20% take the bus, 25% bike, 25% they prefer biking. Okay, and I'd like you to be aware that anytime you have percents, you're going to have a total of a 100%. All right, so they only have here these added together. That's 50%. That's 45%. So 5% is unaccounted for, and they're telling you that the remaining students rollerblade to class. So that remaining 5% that was not accounted for, those are rollerbladers. Because you got to have 100% total. You got to have 100% total. They only accounted for 95%, so the remaining 5% that was never accounted for, they have to be rollerbladers. All right, so it says if each student preferred one method of getting to class, and 75 students rollerblade, how many students were surveyed? All right, so let's take a look at this problem. All right, I'd like you to be able to see here that a percentage is a ratio. First step, identify the ratio. A percent is a ratio. It's saying that every 5 rollerbladers, a percent is a ratio. Every 5 rollerbladers, out of 100 total people, out of 100 total, 5 are rollerbladers. That's 5%. I want you to be able to see that 5%, that's the ratio for this particular problem. All right, so if out of 100 total travelers, 5 are rollerbladers. That's 5%. And then it says 75 students prefer rollerblading. So you should know where to put that 75. If I hadn't labeled, I probably wouldn't have known. But I've emphasized in this show today that you should label. So let's put 75 rollerbladers up top. Let's put our unknown at the bottom. That's step 2, which is to create a proportion. Now step 3 is to cross multiply. So we have 5 times x is 5x. And then we have 75 times 100 is 7,500. Let's divide by whatever's next to the variable we solve them for. We divide by 5. We end up with 7,500 divided by 5. In this case, you get 1,500 or D. All right, so you're looking at 1,500 total people were polled. All of these